8 disciplines. Problem solving is a method used to approach and to resolve problems, typically employed by quality engineers or other professionals. Its purpose is to identify, correct, and eliminate recurring problems, and it is useful in product and process improvement. It establishes a permanent corrective action based on statistical analysis of the problem and focuses on the origin of the problem by determining its root causes. Although it originally comprised 8 stages, or disciplines, it was later augmented by an initial planning stage. 8D follows the logic of the PDCA cycle. The disciplines are, DO, plan for solving the problem and determine the prerequisites. D1, use a team, establish a team of people with product process knowledge. D2, define and describe the problem, specify the problem by identifying in quantifiable terms the who, what, where, when, why, how, and how many for the problem. D3, develop interim containment plan. Implement and verify interim actions, define and implement containment actions to isolate the problem from any customer. D4, determine, identify, and verify root causes and escape points, identify all applicable causes that could explain why the problem has occurred. Also identify why the problem was not noticed at the time it occurred. All causes shall be verified or proved, not determined by fuzzy brainstorming. One can use 5 whys or Ishikawa diagrams to map causes against the effect or problem identified. D5, choose and verify permanent corrections for problem non-conformity, using pre-production programs, quantitatively confirm that the selected correction will resolve the problem. D6, implement and validate corrective actions, define and implement the best corrective actions. D7, take preventive measures, modify the management systems, operation systems, practices, and procedures to prevent recurrence of this and all similar problems. D8, congratulate your team, recognize the collective efforts of the team. The team needs to be formally thanked by the organization. 8D has become a standard in the auto, assembly, and other industries that require a thorough structured problem-solving process using a team approach. History, 8D methodology, despite what is generally thought, was not created by Ford but by the U.S. Department of Defense in 1974. The standard, which described 8D, was named a OEML STD 1520 Corrective Action and Disposition System for Non-Conforming Material. This standard was officially abolished in 1995, but the 8D methodology has been propagated by Ford in the automotive industry and is well known to many companies in the electronics industry. Ford's perspective, the executives of the powertrain organization wanted a methodology where teams could work on recurring problems. In 1986, the assignment was given to develop a manual and a subsequent course that would achieve a new approach to solving tough engineering design and manufacturing problems. The manual for this methodology was documented and defined in Team-Oriented Problem Solving, first published in 1987. The manual and subsequent course material were piloted at Ford World Headquarters in Dearborn, Michigan. Many changes and revisions were made based on feedback from the pilot sessions. This has been Ford's approach to problem solving ever since. It was never based on any military standard or other existing problem-solving methodology. Ford refers to their current variant as G8D. Military usage. The U.S. government first standardized a process during the Second World War as Military Standard 1520, Corrective Action and Disposition System for Non-Conforming Material. This military standard focused on non-conforming material and the disposition of the material. Usage. Many disciplines are typically involved in the 8D process, all of which can be found in textbooks and reference materials used by quality assurance professionals. For example, an is-not worksheet is a common tool employed at D2, and Ishikawa, or fishbone, diagrams and 5-why analysis are common tools employed at step D4. In the late 1990s, Ford developed a revised version of the 8D process that they call Global 8D, which is the current global standard for Ford and many other companies in the automotive supply chain. The major revisions to the process are as follows: addition of a DO step as a gateway to the process. At DO, the team documents the symptoms that initiated the effort along with any emergency response actions that were taken before formal initiation of the G8DDO. Also incorporates standard assessing questions meant to determine whether a full G8D is required. The assessing questions are meant to ensure that in a world of limited problem-solving resources, the efforts required for a full team-based problem-solving effort are limited to those problems that warrant these resources. Addition of the notion of escape points to D4 through D6. An escape point is the earliest control point in the control system following the root cause of a problem that should have detected that problem but failed to do so. The idea here is to consider not only the root cause, but also what went wrong with the control system in allowing this problem to escape. Global 8D requires the team to identify and verify an escape point at D4. Then, through D5 and D6, the process requires the team to choose, verify, implement, and validate permanent corrective actions to address the escape point. Recently, the 8D process has been employed significantly outside the auto industry. As part of lean initiatives and continuous improvement processes, it is employed extensively in the food manufacturing, healthcare, and high-tech industries. Benefits: effective approach at finding a root cause, developing proper actions to eliminate root causes, and implementing the permanent corrective action. Also helps to explore the control system that allowed the problem to escape. The escape point is studied for the purpose of improving the ability of the control system to detect the failure or cause when and if it should occur again. Finally, the prevention loop explores the systems that permitted the condition that allowed the failure and cause mechanism to exist in the first place. Disadvantages: requires training in the 8D problem-solving process as well as appropriate data collection and analysis tools such as Pareto diagrams, fishbone diagrams, and flow charts. Problem-solving tools: the following tools can be used within 8D: brainstorming, trend charts, 5Y or Euro unregistered trademark S, storyboards, scattered diagrams, surveys, check sheets, histograms, fail-safing, Pareto diagrams, fishbone diagrams, flow charts. Relationship between 8D and Fmea. Fmea is a tool generally used in the planning of product or process design. The failure modes in an Fmea are equivalent to the problem statement or description in an 8D. Causes in an Fmea are equivalent to potential causes in an 8D. Effects of failure in an Fmea are problem symptoms in an 8D. The relationships between 8D and Fmea are outlined below. The problem statements and descriptions are sometimes linked between both documents. An 8D can utilize pre-brainstormed information from an Fmea to solve problems. Possible causes in an Fmea can immediately be used to jumpstart 8D fishbone or Ishikawa diagrams. Brainstorming information that is already known is not a good use of time or resources. Data and brainstorming collected during an 8D can be placed into a Fmea for future planning of new product or process quality. This allows a Fmea to consider actual failures, occurring as failure modes and causes, becoming more effective and complete. The design or process controls in an Fmea can be used in verifying the root cause and permanent corrective action in an 8D. The Fmea and 8D should reconcile each failure and cause by cross-documenting failure modes, problem statements and possible causes. Each Fmea can be used as a database of possible causes of failure as an 8D is developed. See also, corrective and preventive action, failure mode and effects analysis, fault tree analysis, quality management system, problem solving, RPR problem diagnosis, references. External links: Society of Manufacturing Engineers, SME, 1.